Okay, we shall continue. Okay, this was the question we were trying now. So in the stress concept method, you see here already we have P by A, which is your direct stress. Then we have your stress due to this movement, which is developed due to this load. Right. So we have a stress at the top and stress at the bottom. Now, when we try to solve this same question, in the strength concept method, what happens, the stresses, since the beam is same, the pre-stressing force is same, so your stresses developed will also be same at the top and at the bottom. Okay, but the methods are different only. Okay, so now when we try to solve this particular question with the strength concept method, it is what, this one. See here also you get your stresses at the top 7, stress at the bottom 1, similar to the stress concept method. Now how to proceed here,
Ma'am,
huh?
ma'am, your screen is not visible, ma'am.
Oh, now is it okay now?
Yes, ma'am.
Mm-mm. Okay, so and now, since you see here, top stresses were 7, 1, bottom stress was 1. Now, when we proceed with the strain concept method, what will happen? The stresses are same here. You can see stress at the top 7, similar to the stress concept method, and the stress at the bottom. Why? Because the loads are same, the pre-stressing force is same. Obviously, here the stresses will be same here. So stresses will be same here. Now how to proceed is that here in this particular question we have to find out, now this was our P line, now we have to find out how much shift has your C gone. That means where is your C line now, how much it has been shifted from the P line, which is given by, already we know M by P. M we had calculated, which was our 72 kilonewton in this particular question. So 72 kilonewton. Now, P is what? P is your pre-stressing force, which is given to you to be here. This one, 960 kilonewton. So you get how much? Your eccentricity of the C line to be 75. Okay. So that means your eccentricity is how much? 75. Other here, 75. Your C line is here. Okay. So how much is your now the stresses? C by A we know, plus minus, here already we had known that how much is your extreme stresses, C by A plus minus CE by Z, which is the eccentricity of the C. So here we got our C we know, which is your this P. A you know this one. CE, which is the moment due to this eccentricity, is how much? CE by Z. E is your 75. Okay, so in this way we get our stresses, that is 4 plus minus 3 Newton per mm square, and the stress at the top is 7, stress at the bottom is 1. Okay, the stress strength concept method, this was the difference between the stress concept and the strength concept method. Now if we do another problem here, this one, a pre-stressed concrete beam, this much, this much, this much. Mm. Hello? Hello? Hello?
Yes, ma'am.
Uh, are you viewing my the screen?
Yes, ma'am.
Is the
But
screen visible? The problem is showing, no?
no, ma'am. Problem is not showing that
Yes, we
signing
can see, we can
something is
see
wrong.
your screen.
Only the screen, but not the solution, no?
No, ma'am. We can't see the
Not the
solution.
Now, one minute, let me check what is happening. Now, is it okay?
Yes, ma'am.
Oh God, okay. Now, the next question you see here. a pre-stressed concrete beam this much in section has a
Sure.
span of 6 meter and is subjected to a UDL of 16 kilonewton. Same. The precession tendons are located at the lower third point. Whenever it is mentioned that lower third point, we know that our eccentricity is how much from the center. It is 100 because here it is 600. See here, if we have the section and at the center lower third point, so this was our 300. This is also our 300 and our tendon is here at 100 mm. So now we know in the stress constant method we already know that there is a eccentricity here because this is our P. There is an eccentricity here with the CG. This is the CG. This is the P. So we have an eccentricity here. So now what will be the stresses developed? The stresses developed will be P by A, which is the direct stress, and the stress due to this load, the moment which is developed due to this, there will be a stress here plus minus M by Z, and due to this eccentricity in the tendon from the CG, there will be a stress due to this eccentricity PE by Z. Stress which is developed due to that eccentric moment is minus plus PE by Z. We know these things. Right. Now, same thing when we consider the strength constant method, what has happening here, you see, in the strength constant method, we know that we have to calculate the C line method. Where is our C line method? First of all, you have to calculate that because everything is considering the C line only. So we have to find out how much is the shift of the C line from this P line. So what was that? M by P. Now M we know our moment 72 kilonewton meter. Then we have P we know 960 kilonewton. So 75 mm is our shift of the C line from the P line. Okay, so that means what? When you have this beam like this is the center, this is your suppose the P line. So now this P was at a distance of 100 mm and you have a shift of this P line. This P line, this is the P line at 100 mm from the CG. Now what is our shift of the C line from the P line is 75 mm. That means from here up to 75 mm is your this one C line. This is your this is your C line, which is 75. So that means how much from this 100 from the CG till the P, what was the distance? That eccentricity was 100. Now we know that our C line has shifted from the P line 75 mm. So that means how much is the eccentricity of this C line from the CG? 100 minus 75, which is 25 mm. So 25 mm below the centroidal axis. So this is our basically the eccentricity which we are going to consider in the strength constant method, eccentricity of the C line from the CG. So now we know what there is a load already. We know what was that load. That load was 16 kilonewton. So we have how many stresses? This direct stress C by A and the stress one stress which is due to the effect of the this C line's eccentricity. Okay, that is CE by Z. Okay, so minus plus CE by Z. Okay, see whenever your this is your CG, whenever your C line which we have to consider. If that is below the CG, that means what? Like earlier we used to do what? The pre-stressing force, pre-stress, that is a tendon, was below the CG, and then what we used to do, we had a moment due to the eccentricity, and that moment due to eccentricity was how much? Minus plus PE by Z, minus plus, because it is below the CG. Your this eccentricity is below the CG, so your moment is like this due to the eccentricity, so minus plus CE by Z. Okay, here we already know these things. So stress at the top is how much now? Stress at the top is this. The total stress was 4 minus plus 1 Newton per mm square. Stress at the bottom was 5 Newton per mm square. So you can see here this is same. So basically there is no difference, only the methods are different. Either you solve it by this method, or stress concept method, or strength concept method. Okay, section B. Can you give me your enrollment IDs? Only half of the screen is visible. Was it only half? Your screen, my screen? There is, take a picture of this. The Lency. Anita. Yes. Everyone gave your enrollment IDs. I'm just clicking photos, okay, of your enrollment IDs, whatever you're sending me for your attendance. And I'm sorry whatever happened today. I don't know why it was happening like that. My laptop is not working properly. Not Taga. Everybody done attendance? Okay. Goa Manju. Before she got disconnected and is not able to rejoin. Okay. I hope everybody has given you enrollments. So this was your strength concept method. Okay. Now if we see this particular question, please note down this question. Note down this question. Here we will do the solve the problem in all the three methods, which is the stress concern method, load balancing method, and the strain concern method, because in those simple concentric tendons or with an eccentric tendons without a bend, you cannot do the load balancing method there. So we are now we'll do here all the three methods in this particular question, so you can note it down your this question. Here, all the three methods will solve together. Stress consent method, then we have the load balancing method, then we have the strain consent method, or the P line you can say, or the C line method, or the pressure line method. So, what is the question here? This talk has some. So here in this question, what you have, a precious concrete beam this much is bent as shown in the figure. The external load on the beam consists of a concentrated load of 180 kilonewton. At the midspan, it is if the effective pre-stressing force is 1200 kilonewton, calculate the extreme stresses in concrete for the midspan section. So here if we first of all solve this problem by the stress concept method, what will happen? This is your stress concept method, where you have the area section modulus. We know already for the particular dimensions, P is this much, so dead load will be how much? W, this one, the dimensions are given, this into this, so that is your 6 kilonewton, this one. Then comes your now the bending moment. Now the bending moment will be due to this WL square by 8 and due to this point load. Now what is your WL by 4 is your point load, because we are doing by the stress concept method. So we are not trying to balance this with an upward thrust, but we are just finding out the moments due to the load, which is these are the loads UDL and a point load. So the total load, external bending moment due to the total loads is 297 kilonewton meter. And so we have the different stresses are what? Direct stress, then we have the stress due to the bending moment M by Z, and we have a stress due to the eccentricity, okay, which is your P E by Z. So E is what you're at the midsection, we are finding out these stresses. So at the midsection, your eccentricity of this particular tendon with the CG is 140, and we are following the stress consent method. So PE by Z, and at the bottom your eccentricity is, so you have the moment is at the top you have tension, at the bottom you have compression. Now we got our total stress to be at the top to be 10.4 Newton per mm square, and at the bottom we got how much? Minus 4 Newton per mm square. Now the same question, if we try to solve by the strain constant method, what we have? We know we have to find out the calculate the C line shift of the C line from the P line, and how much is that? M by P. We got it to be 247.5 mm. Okay, so, and the eccentricity of the, now we can calculate here. We got how much? The shift of the C line from the P line to be 247.5 mm. Okay, so if we do here, this was 140, we have how much? 247 something. So suppose it is somewhere here till here, 247.5 mm. Now eccentricity of this is the, that means eccentricity of the C line. This is the eccentricity of the C line from the P line. Okay, so now what is the eccentricity of this C line from the CG? So that will be how much? This 247, how much we got? That minus your 140 will give you your this eccentricity. This total minus your this 140 will give you your this distance, which is this eccentricity of this C line from the CG. So that is how much? 107.5 mm. So that means this is your, this portion is your 107, 107.5. Okay, so now what are the extreme stresses here? We will know it is C by A, the direct stress, this one. Then we have plus minus CE by Z. Why? Because your eccentricity of this bend tendon from the CG is at the top, and so we'll have a compression here. The moment is in that way, this way. So we have a compression, and at the bottom we have tension. So it is plus minus CE by Z. So you will calculate and you will find out how much it is your same. Top stress is 10.4. Then we have the bottom stresses minus 0.4 Newton per mm square. Now the same question again if we do by the load balancing method. By the load balancing method, this was the stress constant method, and this was the stress constant method. Now if we do the same question in load balancing method, we know how much it was, 10 theta. This upward thrust, there will be an upward thrust in load balancing method, so it is 2p sine theta. So 2p sine theta, if we do, we have to calculate the sine theta. So you know what is your sine theta here now. Your sine theta is 140 by 3000. Okay, this one 140 by 3000. Okay, so it is how much? Your 2p sine theta, this much value. So net upward load will be how much? 180, the total point load, minus your 112. So that gives you your net upward load, sorry, net downward load to be 68 kilonewton. And the net bending moment at the center will be how much? This much. 129. Now when you know your downward load acting is how much? 68 kilonewton, you can easily find out your this one, the moment due to that UDL and the moment due to the point load, which is 68 kilonewton here. So the total bending moment will be 129 kilonewton meter. Then we can find out our stress at the top in this way, and at the bottom that is same. You can see here also stress at the top 10.4, 4.4, here also 10.4, 4.4. Okay, so this was the difference of the stress constant method. Then we have the strain constant method, or by the load balancing method, for finding out the stresses due to pre-stressing forces. Do you want to note down this question? Have you noted down? Understood these three differences, the stress consent method, strain consent method, and the load balancing method? Hmm? Okay. We have the other one. Although this much is okay for you. I can give you one. Please note this question. Try this question. Find the this one. 16. Find the cable day page for the beam shown in figure. This figure. This one. Very easy. Roughly just calculate in give your answers. What can be your cable dip age? How much is your dip? Anyone? How much is your dip for this question? 16. So this was the general load balancing method question. Simple load balancing method question where you had to calculate the age, where we used to equate both the upward thrust and the downward thrust. Did you try? Anyone? Very simple.
And WL by 3P.
WL by 3P. Himal also WL by 3P. Yes, correct. WL by 3P. So how you have done this? We have considered this portion because it is whether this upward force or this upward force it will be same. So we can consider this particular portion and then we can find out what is our tan theta. We know H by L by 3. So that is how much 3H by L. And other one is what we will find out. We will equate these two since we are balancing the load. So downward load is equal to your upward load, which is P sine theta, and sine theta was our how much? Tan theta, which is 3H by L. So dip is WL by 3P. They are correct. So this kind of questions are asked sometimes. So again, if we see one more question, let me see. Sure. We have almost done the all the methods and all some types. Correct. Okay. Take down this question for your as a homework. Please take this question, this one. 40. Take this question and find out the stresses by the uh, strength concept method. Okay, note down your this question, and in the next class you uh, okay, in the next class give me the answers. I may ask you to submit in like the assignment. Okay, I'll take this as an assignment too. Assignment 2. Okay, try to solve, and then I'll be sharing a link. There you can drop your assignments. Take this question. Okay, try to solve by strength concept method. Okay, uh, you don't need to do load balancing, or you don't need to do the stress concept. Just in short, you can just solve the stresses. You can calculate at the midspan section. Okay, wait, let me check what is it in here. Beam within a determine the stress at the end section and mid section, right? So you do one thing, you don't write, you don't need to find out the end section, just find out at the mid section with the help of your what is it called, strength concept method, or the P line, C line, whatever you can say. Only the mid section you find here, on the mid section, the top and the bottom stresses. Let me write it. Determine the stresses at the midspan section with the strength strength concept method. This is a question for the assignment 2. This particular question is design question number 40. The above strength concept method. Okay. Okay, done everybody. Taking noting down this question. We can then stop the class for today. This is also going to end. I'll stop sharing my screen now. Okay. I'll share also the attendance on the this thing group. If somebody is present, mention there. Okay, thank you.